So hi everyone, today we are going to complete regression analysis, and what we did before was to look at simple regression analysis, where we looked at the effectiveness of one variable to the dependent variable, and today we're going to combine all of them, and so this is what we call multiple regression analysis. So it's not as such difficult if we have understood simple regression analysis. In this case, we're going to combine all these variables, call them x's, and salary will be dependent variable, which will be y. So we can write salary as a function of each one of these, being x1, x2, x3, x4, 5, and x6. And so we still have to consider etc, meaning that there are some other variables which are not considered now that may have effect on salary. So in this case, we can write regression model, but before we write regression model, we have to hypothesize, and in this case we can say the null hypothesis mean that the slope of each of these variables equals to 0, so b equals to 0, and in this case we will consider 95% confidence level, and our alternative hypothesis will be that the slope is not equal to 0, and in this case we need to prove it by finding the p-value, which should be less or equal to 5%, which is significance level. And so having this, we can now create our regression model, which will be either salary, or we can say y equals to, first of all, y-intercept, which is a, plus the slope of x1 plus b2, or the slope of x2 plus the slope of x3 plus, in this case we are considering plus because we think that they all have positive relationship with the salary. Otherwise we could put minus if we think that there is a negative relationship. For instance, if we think that gender has negative relationship with salary, then gender could be B4. So we could say, instead of plus, we could just assume in this model that gender is negative, and so we look at the negative slope, which is B4 x4, and department can be positive, so we're gonna put B5 x5, and also the number supervised, meaning that if you're supervising more, your salary will also be, if you are supervising many people, your salary will be more, so that will be a positive relationship. And so we have B6 x6, and then we can write the error term, so that will be E. Now we would like to estimate this y, and we're going to estimate based off this equation here, excluding E, and therefore, so in this case we can write y estimate, which will be equal to A, which is y-intercept, B1 x1. In fact, I'll copy this. Let me copy this. So this is y estimate where we are not considering E, and therefore y is estimated only by the variables that we have. And so if we could include the error terms, or the error term, then that could be the y, which is this existing information. But because we're not considering other factors, then we can only estimate y. And once we have this, then we can run regression to test the slopes of these variables. And all we're going to do is we will just go to the file, because this is the first time for me to use this computer. Let me go to the file and go to the option, and in this case I'm going to add ins and then go. I'm going to select the analysis toolpath, click OK, and therefore if I click on the data, I have data analysis, and in this case I'm going to use regression as we have been doing. And in this case we will consider Y range as our salary, and X range now will be not only one variable but all these variables. And so I'm going to highlight from the labels, and so check here that labels are included. We will still consider 95% confidence level, and the output range I'd like it to be within this page. Otherwise you can look for another page or another place where you want it to be. And output range, okay, I have to click here and then show the output range. I want it to be just around here, and I will consider residuals. If you want, you can plot standardized, you can have standardized residuals or normal probability plots or residual plots, but I'm not going to consider them right now. So the only thing I want you to remember is when you're considering multiple regression analysis, then you will consider more than one independent variable. So in this case, because we are considering all of them, then I had to highlight all of them as our independent variable or the input X range. But I may ask you to just select 2, and then you're going to test only 2 or 3, let's say, but there should be more than 1. And then everything is all set, so I'm going to click OK. Now in this case you can see that when we consider all the variables, we can see that some of them will improve, especially the p-values will improve. But before we go to the p-values, let's look at the multiple R. You can see that the correlation is 0.9, which is good, is almost 1. R squared is 0.8, and adjusted R squared is almost 0.8 as well. So that means the correlation is good, and coefficient of determination determines that this estimation could estimate the actual Y by 80% if we go with the adjusted R squared. So 80% is explained, and the error term will be taken care the error term will be the remaining, which is 20%. Now if we can explain the salary by using all these variables for about 80%, that will be actually a good estimation. We could improve it more, but that's okay. And in this case, now we can come down to look at the coefficients. So you can see that the y-intercept is this value. Years of previous experience is negative, which is weird, but that will be explained by the p-value. You can see that the p-value is 0.61, which is greater than 0.05. So years of previous experience has nothing to do with the salary. So I'm going to go here and I'll put it red to show that years of previous experience has no effect on the salary. Now let's look at the years employed. Years employed gives us this coefficient, which is 621.06. That is the coefficient of years employed, but we will validate this amount by looking at the probability value. You can see that this probability value of 1.457 exponential 0.5, then that means we have 0.601457, and it is actually almost 0. So the p-value here is 0.00, and it's less than the 5% or 0.05, and therefore this coefficient is this coefficient of years employed is effective to the salary. So now we can explain this, that a year of previous experience will add $621.06 to the salary, and that is significant. The significance of this value is determined by the p-value. Now let's go to the years of education. You can see that years of education is 1,631.83. However, this amount should be validated by the probability value, and in this case you can see we have the exponential of 5, so that means we have to count 5 zeros. So we have 0.00000600767. So that means the probability value is almost 0. It is it's 0.00, and it's less than 5%. So this amount that can be added to the salary by having a year of education is significant. And so we can say that a year of education will add this amount to salary, and this amount is significant. Let's look at gender, and in this case we can see that we have negative, and in fact in our model we consider this to be negative. So that means your gender will determine how much you earn, and if you're in a certain gender, then your salary will be less for 1,654.07. However, this amount can be significant if depending on the probability value. So if you look at this probability value here, you can see that it's 0.295, and in this case this is greater than 0.05, and therefore this amount is not significant. So I'm going to highlight this as well to show that this variable is not significant. And then we are going to look at the department. We can see that the department you are in will give you this amount. If you move from one department to another, it will give you 2,134.29. But that amount can only be significant depending on the probability value. So let's look at the probability value. The probability value in this case is 0.001497336, and this amount is less than 0.05, and therefore we'll say that this amount is significant. So if you move if you move from one department to another, you're going to earn this amount, and this amount is significant. So let's go very quickly to the department. Here you can see we have department, and they are organized from 1, 2, 3, 4, and we have sales as the first department, the second one is purchasing, the third is advertising, and fourth is engineering. So that means if you move from sales to purchasing, it's estimated that your salary will increase by 2,134. So when you move from one department to another, your salary will differ by this amount. And this is because the probability value supports this, meaning that it will be, this is significant. Now let's look at the number supervised. And now you can see that if you are having additional person to supervise, will add to your salary by 134.014. Now we will try to find if this amount is significant. We don't compare the coefficients. All we look for is the significance of the value. So number supervised will add 1034.01. So is this amount significant? Now to answer the question, we will look at the probability value. You can see the probability value in this case is 0.14, and that is greater than 0.05, and therefore we can say that this amount is not significant. So your salary doesn't, the salary of these individuals don't depend on the number supervised. Whatever they get is not significant by having an additional person to supervise. And this amount is not significant, not because we are comparing the coefficients, but we are looking at its significance through the probability value. And you can remember our assumption here. It says we will reject the null hypothesis if the probability value is greater or equal to 0.05. If the probability value is greater than 0.05, then we will fail to reject the null hypothesis, and the null hypothesis says that the slope is almost 0. And that's why any probability value that was greater than 5% states that the slope or the coefficient, whatever, any value we have, is not different from 0. So that's all with the multiple regression. And as I said, I may ask you to combine 2, 3, or not more to do the analysis and see what you can get. Now remember, you explained and I asked you to follow some procedures with simple regression analysis. You can do exactly the same with this multiple regression analysis. Thank you.